Okay, example 2. Solve triangle ABC if A is 57 degrees, A is 15 feet, and C is 20 feet. The last one I had that nice computer-generated drawing and everything. This is me for real doing this on my paper if I'm drawing it. I kind of anticipate an acute triangle. It doesn't matter. If the measures come out of 2, so be it. So just draw it and then put A, B, and C in there. Alright, so identify it as triangle ABC because that's what they call it. Solve triangle ABC. So name it what it is. And then start identifying what they give you for information. A is 57 degrees. If they give you a side measure, 15 feet in this case, make sure that that goes opposite the right angle. So A is 57, side A, opposite angle of A is 15 feet. And side C, which is opposite angle C, is 20 feet. Alright, so again, they give me 3 pieces of information. That's what they always do. They give you 3 pieces. Looking at the 3 pieces they gave me, they're in the side-side angle order. So as soon as I see that, step 1 is to go ahead and use the law of sines to find the missing angle that's opposite the side you know. So this side is opposite this angle, both known. Angle C is unknown, but it's opposite a known side. So if I just use the law of sines with that in particular, I know that 15 over the sine of 57 degrees is equal to 20 over the sine of C. Okay. The last time we used the law of sines, we knew all the angles, so we had sine of angle, sine of angle, sine of angle. We knew. We had the ability to use a calculator. Now I've got sine of unknown, so I'm going to have to use an inverse sine button in order to work this one out. As before, though, sine of 57 degrees, I can punch that in my calculator. Sine 57 equals 0.8387. So now if I go ahead and cross multiply, this product, 15 times sine of C, is equal to this product, which is 0.8387 times 20, 16.774. So now if I divide both sides by 15, I get sine of C is equal to 1.1183. So all that is step 1. Seems kind of like a lot to do on step 1, but step 1 says use the law of sines to find the other angle, right? Okay, so sine of C is equal to 1.1183. That means that C is equal to the inverse sine of 1.1183. What do we know about that?
Can't happen.
It's not possible, right? This cannot be bigger than 1. You can't inverse sine anything bigger than 1 or less than negative 1. It's got to be between negative 1 and 1. This is impossible. That means no such triangle is possible. Alright? The reason why that happens, if I was to draw this for real to scale, do this here. So let's just say that there's my third side, that's 15 feet, okay? So, if this is actually 15 feet drawn to scale, that's 20 feet drawn to scale at a 57-degree angle, this side's not long enough to hit the third side. That's what happens sometimes. Again, if you drew it to scale, that's what you can see. In fact, let's just real quick draw it to scale. We can see that. If I get a ruler out, and let's just say, let's say that every one of these is 4. So 4, 8, 12, 16. No, let's make it 5. 5, 10, 15, 20. So do that. We'll make it bigger. Okay. Oops. All right. So if I take that and go to a 57-degree angle, like so. All right. Then I take this and put it up here at the 4, right? I'm going to shrink that up. And then my third side would be down here, like so, right? So if I take this and then I go around it in a circle like this, we're looking for where that 3 hits the bottom. I don't know if I'm trying to get out of the way here. See, right there's an 90-degree angle, it doesn't even reach. See? So going up 20 at a 57-degree angle gets you so high that you can't get back down to the third side with a 15. You have to be at least whatever that is. 3.4 times 5, about 17-ish in order to hit. Okay, so that's what happens, and again, it happens sometimes. So that's what it looks like when it doesn't work, and it's going to happen occasionally. More often than not, it's going to work. All right, so more often than not, it's going to say sin of c is equal to something less than 1, which gets you an answer, and that answer is the acute version, and you get the obtuse version and do all the other stuff with it. All right, and we'll do that in example 3 when we get to it.